Right then, so this is a video for integration by substitution. So you've been starting with this in class, so this is just further examples to support you, okay? So I want to use the substitution u equals 2x plus 5 to find that integral there. So I'm going to let I equal the integral of x times the square root of 2x plus 5 with respect to x. And we're going to let u equal 2x plus 5. Okay? So what we need to do then is we're going to use that substitution to replace all the x's, including the dx, in the integral so that we can integrate it. So as well as having a substitution for 2x plus 5, because we have an x in front of the square root sign, it would be an idea to get a substitution for x as well. Okay, so u will replace 2x plus 5 now underneath the square root sign, and u take away 5 divided by 2 can replace the x. Now we just need to replace dx, okay? Because if we replace the other things I've just mentioned but still have the dx, we'll be integrating with respect to x, which we don't want. We want to integrate with respect to u. So that's going to be du over dx is equal to 2. Okay, we just wait a few minutes while I just erase that. I don't know why I'm using the erase button, and I could have just deleted it off. Okay, so let's just shrink that and move it up out of the way. Okay, so now using du by dx, if I take the dx across the other side, okay, and bring the 2 back down the other side, I could just say that a half of du is equal to dx. So all I've done is I've taken the dx across that side and I brought the 2 back down to the other side. Okay, so I've swapped them round. So that gives me a little substitution for dx. So if we stick u equals 2x plus 5, change the x into u, subtract 5 divided by 2, change the dx into half du, that's going to mean that I becomes the integral of u subtract 5 over 2, oops, just forgot the integral sign, multiplied by, so the 2x plus 5 gets replaced by u, so that's going to be multiplied by the square root of u. So let's just write that as u to the power of half. It'll be easier to simplify in a few moments. And dx is going to change to half du. Okay? Now it still looks quite messy. Slightly less harder to integrate though than the original one. Okay, so as long as we tidy it up. So, first things first, if I multiply the two halves together, I get a quarter, and I could, as a constant, I can just take it outside. That leaves me with u to the power 5 multiplied by u to the power half with respect to u under the integral sign. Okay, so if I expand that bracket out, I'm going to get I is going to be equal to a quarter multiplied by the integral of u to the power 3 over 2, and that's u multiplied by u to the power half would be u to the power 3 over 2. Take away 5 multiplied by u to the power half with respect to u. Alright? Now that, compared to the original one, is far easier to integrate. So using a bit of substitution, which you learnt in, what, Key Stage 3, you reduce that original integral problem down to something that you would integrate in C1. Okay? So that's going to integrate to that. So u to the power 5 over 2 divided by 5 over 2 minus 5 u to the power 3 over 2 divided by 3 over 2. Okay? So now we just need to start tidying that up. So let's just shrink these a little bit smaller to give me a little bit more room. Room here. And that one as well. If you go, you can still see that. So I is going to be a quarter multiplied by 2u to the power 5 over 2 divided by 5 minus 10u to the power 3 over 2 divided by 3. Okay. If we expand all of that, the 4 in the denominator will cancel with the 2's and the 10. So I will get u to the power 5 over 2 divided by 10 minus 5 u to the power 3 over 2 divided by 6. Okay? And now, what I do is I replace the u's with my original substitution. Then it looks like I've integrated x times the square root of 2x plus 5 with respect to x. So therefore, I is going to be 5 over 2 divided by 10. Subtract, just run out of room, so just shift over for a second. 5 multiplied by 2x plus 5 to the power 3 over 2. I squeeze it in. And divided by 6. So shrink that down there. Let's just move it back so you can see everything again. And don't forget the plus c, because it's indefinite integration. So I've just left that at the end. Okay? And then that's our answer. So using substitution, what we've done then, just to recap, is we've used that substitution there. Okay? We've changed the 2x plus 5 into u. Okay? From that original substitution, we've rearranged it and got an expression for x. So we've been able to change that x into u subtract 5 divided by 2. Okay? We then differentiated that substitution expression to get du by dx is equal to 2. Rearranged that to get an expression for d of x, so dx, sorry. And then all those things we've worked out, we've fed that back into our original integral. So we've changed the x, we changed the 2x plus 5, we changed the dx, tidied all that up, and we've ended up having something a lot easier to integrate. Okay, so the actual integration process then is a lot easier. Okay, and then what we do is to go back to what we were originally asked to integrate. We just change that original substitution back into the expression involving x. So the end result is the integral of x multiplied by the square root of 2x plus 5 with respect to x, which is quite a very clever technique, really. Okay, let's try another example. Right, so next example, we're going to use the substitution u equals sine of x plus 1 to find the integral of sine 2x, brackets 1 plus sine x to the power 3. Okay, now this is a little bit more challenging. Okay. One of the problems we've got is we've got to replace sine 2x using a substitution that's only got the sine of x in it. So we want to think back to our trig identities. I think the first thing we're going to want to change is that sine 2x. Okay, and see where we go from there. All right. At the moment, we can change the 1 plus sine x to the power 3 into u to the power 3. That's the same as sine x plus 1, isn't it? Okay. So that allows us to do one thing. Okay. So therefore, du by dx is going to be equal to cos x as well. So that'll help us to get an expression for dx. So if I just swap those two around, that's going to give me du over cos x is equal to dx. All right. So the thing that's caused us an issue is the sine 2x term. All right. Because there's nothing I can do to substitute in for that at the moment. So we leave that for now. So let's just change our integral to what we've got so far. So we keep the sine 2x, we can change 1 plus sine x to the power 3 into u to the power 3, and we can change the dx into du over cos x. All right? So the way you want to approach these problems is kind of have like two columns. So you've got your working out column on the left, and then you're feeding things in. So you're changing that integral a bit by bit until you get an integral that's all in terms of u. Okay? Now what we're going to use here is, if you haven't thought of it already, is the double angle formula for sine. So from C3, if you recall, sine 2x can be rewritten as 2 sine x cos x. All right? So we replace sine 2x with 2 sine x cos x. Actually, the cos x will end up being divided by that cos x that's already there on the orange expression. All right? So let's just change that first of all. So we've got 2 sine x cos x times u to the power 3 du over cos x. All right? Cos x's can cancel. Just immediately making it a lot easier, look. Okay? The 2, as is a constant term, I'm just going to take that outside of the integral to simplify it a bit further. So I've got I is going to become 2 times the integral of sine x times u to the power 3 with respect to u. Okay, so we still can't integrate at the moment because we've got that x term in there and we're integrating with respect to u. So we have to substitute now an expression for sine of x. So we go back to our original one, look, which is in terms of sine x. If I take the 1 across the other side, sine x is going to be the same as u subtract 1. So if we change that now then, so let's just write that on our left-hand side first of all. So we know u is sine x plus 1. So therefore, if we take the 1 across the other side, we can say sine of x is equal to u subtract 1. And then that is it. That's our substitution process done. That's going to leave us with I is going to be equal to 2 times the integral of u minus 1 multiplied by u to the power 3 with respect to u. So if we multiply that out, we've now turned that into really basic integration to get our answer. So that's going to be 2 times the integral of u to the power 4 minus u to the power 3 with respect to u. So that's the kind of integral you did when you first started learning about integration, look. Okay? So it couldn't be simpler. So that's going to give me 2 brackets u to the power 5 divided by 5, subtract u to the power 4 divided by 4. Okay? Running out of room where to put things at the moment. Yeah, let's just shift everything up a little bit actually. Okay? There's a lot of working out involved. The more written working out you do with these questions, coincidentally, it does make it easier. Okay, so if we multiply that out, we're going to have I is going to be equal to 2u to the power 5 times 5. Take away u to the power 4 divided by 2 plus the c. It's not quite finished yet. Now we go back to our original substitution of sine x plus 1 to get our final answer. So our integral is going to be that, but with sine of x plus 1 written in place of the u's. So we'll have 2 brackets sine x plus 1 to the power 5 divided by 5 subtracted by sine x plus 1 to the power 4 divided by 2 plus the really important arbitrary constant c. That's it. Actually, very powerful method. A little bit confusing to start off with, but ultimately allows us to integrate some really tough expressions in a very, very simple way. Okay? So, like I said, just to repeat, the key, I think, to make it easier is to have some working out on the side, on the left-hand side or the right-hand side, away from your main work, and you just work out little substitutions, substitute it a bit by bit, line by line, simplifying it, seeing how it changes until eventually you get down to an expression where it's all in terms of u and you're respecting, so you're integrating with respect to u, and then you go ahead and do the simple integration to get your answer. Okay, so you want to have your substitution working out on the one side and your actual integrating work on the other side. So try not to mix up the two. Okay, and like I said, just take it in steps. Right, before you start the exercise, you might want to just watch the next video, which is integration by substitution part 2, which we just look at some slightly harder ones. Okay, we're going to look at integrating log and doing definite integration with it as well. Okay, so off you go.